Hello, today's topic is permanent magnets and electromagnets. Now, the material is selected based on the hysteresis curve. So, first we'll see what are permanent magnets, and then we'll see what are electromagnets and how to select the material based on their retentivity and coercivity. First, we'll learn about permanent magnets. So, what are permanent magnets? As the name suggests, their magnetic property will remain for a longer period, permanent. So here it's very clear that the magnetic property, this material will have their magnetic property for a longer period. Generally, we use ferromagnetic material for permanent magnets and electromagnets. We do not take dia and paramagnetic materials, because we know ferromagnetic material we can easily magnetize. So for permanent magnets, what we take is do is, like, we take substances which at room temperature retain their ferromagnetic property for a longer period. So we can write permanent magnets are substances which at room temperature retain their ferromagnetic property. For a long period of time. Are called permanent magnets. So which material can we select, like ferromagnetic property? What are the examples? Like, can we take steel or iron? So how do we select it? So the magnets are selected based on materials which have high retentivity, high coercivity and high permeability, because they have to maintain their magnetic property for a long duration. Therefore, we can choose materials or ferromagnetic materials which have high retentivity, high coercivity and high permeability. So you can see the hysteresis curve, and you can select a material which has high retentivity and high coercivity. Permanent magnets are made of materials having high retentivity. That means high retentivity itself means that they can retain their magnetization property, though you remove the magnetizing field. We have seen what is retentivity and what is coercivity. So high retentivity means that they can retain their magnetizing property, or it is actually the residual magnetism which is left after the magnetizing field is reduced to 0. Having high retentivity, high coercivity, and high permeability. Anyway, this ferromagnetic materials have high permeability. Both permanent magnets and electromagnets are made of ferromagnetic material only, but they differ in their retentivity and coercivity. High permeability. So an example is steel, such as steel. Permanent magnets are made of materials having high retentivity, high coercivity and high permeability, such as steel. You can have other examples also. Other suitable materials for making permanent magnets are alnico, cobalt steel and Ticonal. other suitable material for making permanent magnets are alnico, that is alloy, alnico, cobalt steel, and Ticonel. So these are some of the examples from which you can make permanent magnets. Now what are electromagnets? So electromagnets are not permanent magnets. So the name itself says electro. So when you pass through an electric current, the material behaves like a magnet. They are temporary magnets. They are not permanent magnets. So once you remove the current, it will get demagnetized. Electromagnets. So remember, electromagnets are not permanent magnets. They become, or they behave like, this material will behave as a magnet only when you pass through an electric current. That is why it is called as electromagnets. Electric current, it behaves like a magnet. So you can take a ferromagnetic material and you can put it inside a solenoid, and when an electric current passes through it, the solenoid produces a magnetic field, and your ferromagnetic material will also behave like a magnet. And once you remove the electric current, it gets demagnetized. So I'll write those things here now, whatever I have just explained. Electromagnets are made of ferromagnet. So what are the property of these materials it should have to become an electromagnet? So they should have high permeability, that is one of the property, and these should have low retentivity, because they should not maintain their magnetizing property for a long period, because we are not using a permanent magnet here. So as soon as the magnetizing field is removed, the material should get demagnetized. So that is why we are using a material with high permeability and low retentivity. But for permanent magnets, we are using a material with high retentivity. Why? Because we have to maintain the magnetizing property once you remove the magnetizing field. But here, a low retentivity material will work. So next you can write electromagnets. So these magnets are made of ferromagnetic materials which have high permeability and low retentivity. So an example can be soft iron, such as soft iron. So how it gets magnetized? So what you can do is place a soft iron rod in a solenoid and then pass an electric current. Now when an electric current is passed through a solenoid, a strong magnetic field is produced, and the soft iron will behave like an electromagnet. On placing a soft iron rod in a solenoid and passing electric current through it, produces a magnetic field. Or you can write, on placing a soft iron rod in a solenoid and passing electric current through it, strong magnetic field is produced. and it behaves like an electromagnet. Electromagnet. When current is switched off, it loses its magnetization effectively. When current is switched off, it loses its magnetization effectively because it has low retentivity. As soft iron has low retentivity. Low retentivity means that there is no residual magnetism left when the magnetizing field is reduced to 0. I can show you the picture also. Like, we can take a soft iron rod, and if you have a solenoid like this, you will have a solenoid, and place a soft iron bar inside this. Then on passing an electric current, a magnetic field is produced and the soft iron rod will behave like an electromagnet. So this is how you can get magnetize this ferromagnetic material, by passing an electric current. That is why it is called as electromagnet. By passing an electro current, you are making the ferromagnetic material as a magnet. And this type of soft iron is used as, in transformers. Some of the examples are of these electromagnets are in cores of transformers, in galvanometers, in generators, etc. We use this soft iron core because only when electric current is passed, it behaves like a magnet. Now if you take hysteresis curve for this soft iron, you will see that the area under hysteresis loop for soft iron is less. That means that the area actually gives us the energy loss during one complete cycle. So in case of transformers or generators and all, there is a repeated magnetization and demagnetization. So the cycle keeps on happening, and hence it has a less area. The energy loss during magnetization and demagnetization will be less. So that is also one advantage of using electromagnets or using a soft iron as an electromagnet, because it has less area, and hence it means that the energy loss during one complete cycle is less. You can write the area under the hysteresis curve is less. Sorry, area, it should be area under hysteresis curve or hysteresis loop for soft iron is less, and hence energy loss will be less. So energy losses during one complete cycle of magnetization during one complete cycle will be less when you use soft iron. Area under hysteresis loop for soft iron is less, so energy losses during one complete cycle is also less in case if you use a soft iron. Therefore, these soft irons are used in cores of transformers, galvanometers, generators, etc. This is why soft iron is used in cores of force of transformers and galvanometers, generators, etc. Okay, hope you understood this. The main thing is, where we have repeated cycle of magnetization and demagnetization, we should use a material which has less area under its hysteresis loop, because that means that the energy loss will be less. So in case if you want a magnet where a repeated magnetization and demagnetization occurs, you can use an electromagnet, and then you can choose a material soft iron. It has less area under its hysteresis loop, and hence that means that the energy loss is also less. Hope you understood this.